Ciba Geigy, research scientists create products which enrich the quality of our lives. Products to increase our food supply, dyes and pigments which surround us with color, pharmaceuticals to improve our health, products which reaffirm the value of science to mankind. As part of its continuing program in support of science education, Ciba Geigy is pleased to present this issue of the Science Screen Report.
The Science Screen Report. Developments in science, engineering, and medicine that help solve the problems of modern life. From Earth orbit, the broad pattern of the world's weather is plainly visible. One of man's oldest dreams has been to control the weather, or at least to predict it accurately. In this century, weather scientists have sought ways to manage the weather, to alter or forecast important weather events. What follows is a report on those ongoing efforts. In the last few decades, scientists have sought to both modify and accurately forecast the weather. This is a progress report on some of those programs. Weather modification includes such goals as making hurricanes less destructive, suppressing hail, and increasing rainfall or snow in specific areas. All these goals depend on a technique called cloud seeding. This experiment explains the seeding process. These water droplets are supercooled, still liquid, although at a temperature below 0 Celsius. Next, a polarized image shows a foreign substance or seed being added and the droplets freezing. Seeding clouds is the basis of most types of weather modification. This is a satellite-made film of a hurricane, a violent tropical storm 700 miles across. Project Storm Fury was set up to learn how to reduce the destructive power of Caribbean-born hurricanes. The hurricane center is called the eye. The dense ring of clouds surrounding it, the eye wall. A hurricane is born when a column of warm, moist air rises from sea level. When this vapor condenses, it releases heat which pumps up more moist air. Some condensed droplets carried aloft are supercooled. At temperatures below 0, they are still liquid. In the past, weather modification missions flew into hurricanes, seeding the supercooled droplets with silver iodide from the maximum winds outwards. In theory, the silver iodide seeds allow the hurricane's supercooled droplets to form ice crystals, which then fall as rain. This process, it is theorized, may also form a new, wider hurricane eye with lower average wind speeds, which would produce less damage. So far, the National Oceanic and Atmospheric Administration has not established that cloud seeding can decrease a hurricane's winds. Today, research efforts have shifted to probing hurricanes to better understand their basic structure and behavior. For the present, seeding has ceased. Hailstorms cause hundreds of millions of dollars in crop damage annually. The destructive power of hail depends on its size. Some hailstones are as large as grapefruit. In general, smaller stones do less damage. Small stones, because their meltwater seeps into the soil, may be of greater benefit than rain, which runs off. For years, the National Center for Atmospheric Research has investigated whether cloud seeding can usefully alter hail formation. Hailstone sections under polarized light show layers of growth and crystal structure, clues to the variations of moisture, temperature, and wind velocity inside hailstorms. Seeding hailstorms again involves causing supercooled droplets to form ice crystals. Here, a camera system photographs the microscopic water and ice particles in their natural suspended state in clouds. The pictures taken inside clouds show they hold a mixture of water droplets and ice crystals. Particles that cause droplets to freeze into crystals are called ice nuclei. Ice crystals can also grow by another process called sublimation, water's tendency to evaporate from droplets and freeze onto crystals. In theory, seeding hailstorms could make more ice nuclei available to the same amount of water in a given cloud. One possible result, a larger number of smaller hailstones. A third research program, Projects Phase 1 and Phase 2, involved seeding Florida area cumulus clouds to show this could increase rainfall. On suitable mornings, Phase 2 aircraft like this one carried out seeding runs. Sensors aboard the planes measured wind directions, wind speeds, ice crystal concentrations, and other data for later study. Data was analyzed and target clouds chosen by the ground laboratory, and the plane directed to those clouds where the seeding commenced. To make the test objective, the substance used was kept secret. On some days, containers held silver iodide. On others, inert sand. On this particular day, rain followed the seeding. But was it man-made precipitation, or a natural cloudburst, or both? Besides precipitation measurements, raindrop samples were frozen and preserved in dry ice for study. In the end, project scientists were not able to prove conclusively that the increased rainfall on seed days during the experiment was due to the seeding. Nevertheless, several cloud seeding efforts by individual states are now underway, together with scientific analysis of their data. Besides weather modification, much research is also focused on improving weather forecasting. Tornadoes, violently spinning air columns with winds up to 300 miles per hour, strike at North America over 800 times a year. A major reason for these prediction efforts. Tornadoes' paths are erratic. One home may be completely destroyed, while the one next door is untouched. University of Chicago professor Theodore Fujita is trying to learn how the funnels form and function, and how to spot them from satellites. He has engineered a machine that simulates a tornado's wind effects. A series of cups turn slowly at the rim, faster towards the center, producing air currents. Suction holes at the tops of the rotating cups cause the currents to flow towards the center, producing thunderstorm-like updrafts. Dry ice in water trays below provides visible vapor trails, making it possible to see the air currents as they form. learn about the tornado's damage effects, small pieces of lightweight material are placed within the airflow. Dr. Fujita and his assistants also monitor weather patterns across North America, hoping to record pre-tornado events. When storm fronts are observed, his team photographs the critical cloud buildup in search of better prediction methods. Development of Doppler radar for forecasting severe storms is another step forward. Once, forecasters could not issue warnings until the descending storm funnel was sighted, usually only moments before it reached the ground. Conventional radar only showed how heavy rains were and could not detect winds at all. Now, Doppler radar can peer into the heart of a violent storm and so detect the birth of a tornado. The key is using the Doppler principle, measuring changes in the returning radar signal, which reveal the motions of raindrops, ice particles, and even clear air. Droplets moving towards the antenna are shown in red. Ones moving away are in blue. Red and blue, side by side, indicate opposing winds, called wind shear. Warmer colors indicate faster moving winds. As the storm matures, this display using conventional radar shows the winds growing stronger. The storm system on the left, 60 miles away and 3 miles high, exhibits conditions which could produce a tornado. A massive storm system is now visible. On the Doppler display, shearing winds, the adjacent blue and red zones 3 miles across, indicate where a tornado may be forming. On the multi-movement display, the storm appears as a field of arrows. Arrows point in wind directions. Their lengths indicate wind speeds. On the average, Doppler radar now allows a 20-minute warning before tornadoes touch ground. Enough time for families to reach shelter. Weather management has proven to be a subtle, difficult scientific challenge. Today's research efforts have been refocused on the basic nature of weather phenomena. Getting back to fundamentals, it is hoped, will enable us to truly do more about managing the weather.
Science Screen Report has been produced by Ciba-Geigy Corporation with headquarters in Ardsley, New York, as part of its continuing program in support of science education.